Alright, welcome to the experiment on electrochemistry for chemistry 1A03 or 1U03. This experiment is fairly simple experimentally, so there's not too much to do and not too much to show you. The one thing I am going to mention is it can be challenging to figure out what you need to do. You need a lot of preparation for this experiment. There's a little bit of an inquiry nature to it, meaning that you're going to have to figure stuff out on the spot during the experiment. So it's really, really important you come in prepared. It's going to make your experience in the lab a lot easier if you do that. I can say if you don't come into this lab prepared without an idea of what you're going to do, you can waste a lot of time trying to figure that out, and it can become very frustrating. So have an idea of what you're going to do before you come into the lab. The major premise is you're going to be building a couple electrochemical cells. Building the cell is relatively easy. You're going to take two solutions, two metal solutions. You've got a bunch of different metals here. You've got some copper, you've got lead, tin, and zinc. What you're going to do is you're just going to simply take your metals, put them into the appropriate metal solution, connect them to the voltmeter with the alligator clips. You'll turn on your voltmeter. Typically best to have it at the 2 volt setting. If you need to get to more decimal places, you can go down because some of the cells have very small potentials. You may want to click it down to 0.2 volts, but in general 2 volts is good. So we've got our cell set up right now. All you need to do is complete the circuit by taking your salt bridge. You want to rinse it off before you put it into another solution, but just use it to connect your two solutions. Now you have a continuous circuit, you can get your reading on the voltmeter. If for some reason you're seeing a negative voltage, all you need to do is switch your alligator clips. You just have your cell backwards, and it's not a major issue. So that's really all there is to creating the cells. You're going to be creating 3 cells in this experiment. The first one you're going to create is just a copper zinc cell. It's a standard cell under standard conditions. Very simple to make. The second cell you're going to make is a concentration cell. Now in a concentration cell, what we're going to use is a low concentration of a copper solution and a relatively higher concentration of that copper solution, and we're going to use that to drive the cell. So what happens in a concentration cell is you have a low concentration, a high concentration, and electrons are going to flow so that you get equal concentrations at some point. Now this will be discussed in class, and you can read how they work. What's the anode? What's the cathode? The big thing you're going to do for this experiment is you're going to have to dilute one of your copper solutions. And to do that, you're going to need to use your volumetric glass, and you're going to need to use the graduated pipette. The best way to use this graduated pipette is to take your bulb, put it on loosely, get all the air out of the bulb by squeezing on it, suck the solution up, and again, just take your hand and cap the top of the pipette. From here, what you need to do is, if you need to transfer 5 mils into one of your volumetric glass to make a dilution, you can say, well, I have 1.8 mils in there, and I can transfer that in. If you need to take 1 mil at one point, you can just slowly release your finger, release some of the solution until you get to the 1 milliliter point, and you can transfer 1 milliliter in. Okay? So when you do your concentration cell, you're going to need to dilute one of your copper solutions, and you need to figure out that dilution factor before you come in. So you're given this equipment, you need to figure out how to do it. You may not be able to do it in one step, you may require 2 steps. The last cell you're going to make is going to be a cell based on any of these possible metals. The TA is going to give you a cell potential, and it's going to be random. It could be anywhere from 0 up to about 1.2 volts. What you're going to have to do is, based on the metals you have, you're going to have to create a cell that matches that potential. So first of all, you're going to have to theoretically calculate what metals do I need to use to get me close to that part. Then you're going to have to figure out which metals are best used for that. So it's very good to have all the potentials, or all the potential potentials, set up before you come into the lab. Then once you get into the lab, when you're given that potential, you want to figure out which combinations of metals to use, and then you're still going to have to change around the concentrations of one of your metals to meet that cell that you've been, or that potential you've been given. So it takes a lot of time, so if you have a lot of things figured out before you come in, it's going to help you during the lab, or at least have an idea of what you're supposed to do before you come in. One of the points of part C for this experiment, or when you have the unknown potential, is to write a procedure. So what you want to do during that procedure is you want to be able to write something down so that if you were to give it to somebody, they could repeat what you've just done. And it's a very important skill for scientists to be able to write down and document what they've done so that people can repeat it. When you're done that part of the experiment, again, a simple write-up of all the potentials that you have versus what you were supposed to have, a little discussion again on centered around sources of error, and then hand in the experiment before you leave.